Welcome back, and I've got a really unusual experiment for you today. I call this one the quantum washing machine. So here's my washing machine. Let's have a closer look at it. So the bit we're interested in is the rubber gasket that runs around the outside of the door. And if you look at it, it's flexible. And this is the bit that actually seals the washing machine and keeps the water in when you actually close the door. And it was that got me thinking about quantum physics. So I was in the kitchen the other day washing some clothes, and something quite remarkable happened. Now, before you say it was quite remarkable that I was actually doing my own washing and not getting my girlfriend to do it for me, even though I'm really grateful to her for always doing my shirts for me and making them look so lovely, what in fact happened was I looked at the washing machine as it was going round and I noticed something really strange happening. So let's head off to FJ's kitchen and have a look at the quantum washing machine. So here's the washing machine going round and round and round. And I was drawn to the kitchen because it was making a real racket. And the reason for that was it was shaking like mad. There was an unbalanced mass in the washing machine of the clothes going round, mainly because they'd formed clumps and they were still very heavy, they were still very wet. And what this was doing was vibrating the whole washing machine. But what was interesting is what was happening to the rubber ring, which was normally circular when the washing machine was shaking like mad. So, have another look at the clips of the washing machine going round and have a look at the rubber ring. And if you look carefully, you'll notice the rubber ring, instead of being circular, has lots of wave shapes in it. But those waves don't go round and round, they stay where they are. And that is the bit that got me thinking about quantum physics. So, what, I hear you say, has this got to do with quantum physics? Well, I've set up a little experiment here to show you how it's connected with quantum physics. I've got an oscillator here, a vibration generator and a signal generator, and I've got a ring or a single loop of copper wire. And that piece of copper wire is going to represent the rubber ring or the washer, the seal on the washing machine. But remember that electrons go round atoms. And we can imagine electrons going around the nucleus in ring-shaped orbits. And they too behave in a similar way to the way the rubber ring behaved in the washing machine. So let's have a look at this. So let's turn on the signal generator and cause the ring of copper to vibrate, just like was happening on the washing machine. So it's shaking now, but you don't see much happen. So the copper ring is behaving a bit like the rubber gasket in the washing machine, but let's turn down the frequency of that vibration, in other words increase the wavelength, and have a look at what happens to the copper ring. And if we get it just right, you'll notice these interesting wave shapes forming, in exactly the same way they formed on the rubber ring in the washing machine. So what I saw with my washing machine was really rather unusual. You might have seen my video on standing waves, the rubber cord video, and that explains the physics behind this in mechanical systems. So on the washing machine, we were getting exact multiples of half waves fitting all the way around the rubber gasket, and it got me thinking, because if you think of the quantum wave nature of electrons, they too behave like waves, and they can only fit at certain radii from the nucleus where there are exact multiples of those half wavelengths. In fact, if you went out slightly further, you'd get interference between the waves and the electron would cancel with itself. It's rather a weird concept. So you would have to go out a bit further before you could still fit multiple wavelengths on exactly. Electrons only appear in certain orbitals, in certain distances from the nucleus, certain energy levels. And the only places they can fit is where there are exact fittings of the wavelengths. 1, 2, 3, 4, 5, I think 1, 2, 3, 4, 5, yes. Half wavelengths we've got here. Other frequencies, other energies, other wavelengths just don't work very well. So the electrons are constrained to very specific places around the nucleuses where the waves of them, the quantum wave nature of them, fits exactly. So, who would have thought my washing machine would have taught me some quantum mechanics? But that's the joy of physics. When you know a bit of physics, you see connections all over the place. It's quite complicated, but I hope it encourages you to look up a little bit more about standing waves in mechanical systems and electron orbitals and their wave shapes. Do hope you enjoyed that video, the quantum washing machine, and I look forward to seeing you again next time.